Hello friends, this is Priyanka. Today we are going to obtain mathematical model for a given electrical network. So let us first observe what is this electrical network. Now here is the voltage V, then resistor R1, resistor R2, capacitor C1, capacitor C2 and inductor L is there. Now if we observe this electrical network, then there are two loops. So we can say that within these two loops there is the different current that is flowing. So this is the first loop which includes voltage V, resistor R and capacitor C1. And within this first loop we will say that the current I1 is flowing. Then this is the second loop where within the second loop capacitor C1, resistor R2, inductor L and capacitor C2 is there, and within this second loop the current I2 is flowing. So here is the current I1 and I2. So we have to write now what is the mathematical model. So we have to write this in terms of voltage. Now if we observe this first loop, then in this first loop there is the input is voltage V. Then what is the voltage across this R1? So voltage V across R1 is nothing but VR1. Then voltage V across this C1 is nothing but VC1. Then voltage V across this R2 is nothing but VR2. And here across this inductor L we can say that VL. And here voltage across this capacitor C2 is nothing but VC2. Now we have to define these different voltages in terms of current. So we have three basic equations that you have to note down in your notebook. When voltage in terms of resistance, then we will use that is V is equal to Ri. So this is the relation in between this voltage and current in terms of resistance, resistor R. Then voltage V is equal to L di by dt. So this is the relation in between voltage and current in terms of inductor L. Then voltage is equal to 1 by C integration of I dt. So this is the equation in terms of voltage and current in terms of capacitor C. So we have to use three basic equations. Now we will write here two different equations for these two loops. So within the first loop there is the voltage V, then here is voltage across this resistor R1 and voltage across this capacitor C1 is there. So we know that how to write the equation, that is input is equal to output. So input is the voltage V and it is given to the first loop. So I will write here equation on the left hand side. I will write this V is equal to, now we have to add this VR1 and VC1. So I will write here VR1 plus VC1, that is voltage across R1 and voltage across C1. Now what is the voltage across this resistor R1? Now if we observe here V is equal to Ri, but R is nothing but R1 and I is nothing but I1 because the current flowing through this first loop is I1. So how I can write this? R1, I1. Suffix we have to give as a 1. Then plus. Now voltage across this capacitor C1. Now if we observe this capacitor C1, it is in between this I1 and I2. So we have to take the difference in between these two currents because we are writing here the equation for the first loop. So while taking difference, we will take I1 first. So what is the voltage in terms of capacitor? So here is the formula. So we can say that V is equal to 1 by C integration of I dt. So instead of I, we have to take I1 minus I2. So I will write here. So instead of C, we will take here VC1. So I will write 1 by C1 integration of I1 minus I2 bracket complete dt. So this is the first equation. So here left hand side is V. So I will give here equation number 1. Then we will move for the second loop. Now for the second loop there are total 1, 2, 3, 4 elements are there. So within these 4 elements, what is the current is flowing? That is I2, and for the C1 there is both the current I1 and I2 is there. So again we will write the equation. Now here input V is not applied directly on the second loop. So there is no input. So on the one side, that is we have to take 0. So we will take here as a 0 is equal to, because there is no input, and on one side we have to add all these elements, that is voltage across all these elements. So how we can write here, that is VC1 plus VR2 plus VL plus VC2. Now we will define this in terms of current. So what is VC1? So C1 is in between I1 and I2. So we have to write here, that is 1 by C1 integration of, we have to take difference. But this is the equation for the second loop, so we have to take I2 first. So I will write here 1 by C1 integration of I2 minus I1 bracket complete dt plus VR2. So VR2 is nothing but, we have to take in terms of current Ri, but R2 is there, so I will say R2, and instead of I will write I2 plus VL. So VL is nothing but L di by dt. So L di, that is I means we have to take I2, because across this R2, L and C2 current I2 is flowing. So I will take L di2 by dt plus VC2. So again we have to use same formula. So instead of C we will use C2. So 1 by C2 integration of I2 dt. So this is the second equation. So these two equations, so on the other side there is 0. So these are the two equations which represent the mathematical model for the given electrical network.